Taxibot, a new innovative system at the airports, has started a service evaluation with Lufthansa at Frankfurt International Airport. The Taxibot team introduces the first Taxibot system taxiing airplanes from gate to runway and back without using their jet engines. The Taxibot is a pilot-controlled vehicle for pushback and taxiing. At November 2012, Taxibot has been tested by 17 pilots from 11 world-leading airlines in Châteauroux, France. Steering is performed by the pilot using his tiller via a rotatable turret and a vehicle steering controller. Braking is performed by the pilot using the regular main landing gear brakes and the Taxibot energy absorption mechanism. All these functions are performed while protecting the nose landing gear from exceeding the allowed fatigue loads in real time. Taxibot operation does not require modification on the airplane. Taxibot is a plug-and-play system which does not increase airplane weight and does not reduce the airplane's cargo space. Most hub airport study results showed no need for infrastructure modification in order to operate Taxibot. Immediate taxiing after pushback eliminating bottlenecks in the gate area, as there is no need to wait for engine startup. Taxibot for narrow-body and wide-body aircrafts will benefit airlines by up to 85% in savings with fuel consumption during taxi. The CO2 emission is also reduced by 85% and the foreign object damage-related costs reduced by 50%. This will make airports more economical and environmentally friendly. Taxibot's return on investment to airliners is only 1 to 2 years. Taxibot reduces gate congestion by 30% to 40% and increases airplanes flow, resulting in major saving and improved airport throughput.
The overall impression is very good. Better than I expected it to be. One big advantage which I just realized today is that when you taxi turns on icy or slippery surfaces, the traction is much better, so you can increase safety in turns on icy or slippery taxiways. I wouldn't change anything at all.
The system is great. The Taxibot is self-explanatory, it's easy to learn and easy to use. It's more or less you feel like you have the engines turned on and taxiing by your own power.
Taxibot is really easy, feeling more natural. You can taxi that plane with the Taxibot without any training, more or less.
I feel really comfortable, especially for the steep turn on the runways and also on the taxiways. I think this is good stuff.
Implementing Taxibot reduces fuel consumption, reducing CO2 emission, reduction in noise, less foreign object damage, minimal changes to the airport, and no additional weight and no reduction in the available cargo space. Taxibot, your efficient, safe and clean solution for taxiing your airplane.
Safety has always been a major concern for ground handling operation, and aircraft incident with GSE is representing a massive cost to the industry. IATA is currently evaluating total cost of GSE damages, direct and indirect, at $4 billion per year. Latest aircraft developments with composite fuselage are even increasing this safety concern, as damages caused by ground support equipment may not be visible from the outside. The safety responsibility may shift from the pilot to the handlers, requiring them to ensure that any incident is reported. To address this challenge and to bring safety, economic, and operational benefit to handlers and airlines, TLD is introducing the Aircraft Safe Docking System. ASD will limit the risk of damage caused by the collision between a GSE and an aircraft by supervising the operator during the ground handling operation. The ASD system relies on a 3D infrared camera installed on the GSE. While approaching the aircraft, the operator will reduce its speed and engage the ASD system. This operation will limit the speed of the machine to 5 km per hour, and a flashing beacon will indicate the ramp management that the safe mode is activated. As soon as an obstacle is detected by the ASD, the system will ask the operator to reduce his speed to 0.7 km per hour via a light on a buzzer. If the driver does not react immediately, the system will stop the machine automatically. The operator will then approach the aircraft with a speed limited to 0.7 km per hour in a perfectly safe condition and finish the docking process. It does not rely on the electronic to act on its behalf, drastically reducing the risk associated to potential failure. But as a risk can never be fully eliminated, the ASD system also includes a collision recorder, a black box. The collision recorder will stop the unit in case of impact and require management to come to the unit to restart it with a dedicated key. An optional diagnostic tool will allow the ramp manager to visualize the complete condition of the equipment during the impact. This will include speed, gearbox status, accelerator and brake pedal position. ASD represents the future of safety on the ramp, and this future is available from TLD now.